Hello, Natroners, and welcome back to VFX with Natron. Today, we've got an exciting episode. Today, we're going to be talking about Disney's SeExpr. Alright? So, and joining me again today is Mr. Tom Morley. Say hello, Mr. Tom Morley.
Hello, fellow Natroners.
Oi. Mr. Tom Morley is a gentleman and a scholar. That's why he's Mr. Tom Morley Esquire.
Okay.
All right. So, with no further ado, why don't you, Mr. Tom Morley, show us what today's live stream is going to be about? All right. Today's live stream, we're going to be talking about this little gem. All right, I'm going to pull that up full screen for us. Today's little gem is going to be this thing called SeExpr, and there's this lovely little editor that Mr. Tom Morley is showing off, and we can see that it has, right now, he's showing us a lovely little 3D sphere that is joined in it, and something... Is the Natron, is the stream actually going? Because I'm not seeing anything.
Yep.
It is going. Okay, you are seeing it. I don't know. Mine's not showing it updating on mine, so
yeah,
I don't
we're
know.
good.
All right, good. Mr. Tom Moore is demonstrating something, so we're going to be using this editor. I should point out, we're going to just talk about it right now, just for a second, that this editor is available, or it's mainly a Windows editor. It's made for Disney, and we're going to be using it. It runs natively on Windows, but we tested it out, and it works under Wine. The only caveat to using it under Wine is that Wine, under Wine, it doesn't actually show all the expression list, but you can open up each of the expressions in the side panel. They're individual files in subfolders, so you can open them up in a text editor, copy the text out, and paste them in. And it does do code completion, which is really, really nifty. So, all right. With that said, I think it's time. Oh, yes.
So what I'll do is I'll put a link to the website for the editor in the stream here, and what you'll do is you'll just go to this little icon here to download it. You'll download it. I think that's off the Google Drive.
All right. That sounds
I'll put that
good.
in the stream.
All right, that's excellent. Thank you very much, Mr. Tom Morley. Now let's jump over into, well, Natron. All right, so here we are in Natron. I want to point out, I also in the background have up our little SE expression editor over here, so we can see some code completion if we need to. But for right now, we're going to focus on Natron. So in Natron, we have two nodes. We have SE expression and SeExpr, and I actually believe it's supposed to be pronounced SeExpr, and the reason is it's a visual programming language, or it's a visual language, and over here it's found under our merge nodes. If we go under merge node, we can see that there's SeExpr and SeExprSimple, and we're going to pull up both. All right, and we're going to pull up that one, and we're going to pull up a merge node, SeExprSimple. All right, and the big difference between the two of these nodes, let's just start with SeExprSimple, because it's going to be the key thing is this is channel based, and one of the things that's nifty about this, you might have. All right, let's first tackle one of the sea dogs in the room. Obviously, we have under our draw nodes, we have these two nodes down here called SE Grain and SE Noise. All right, and if we pull up SE Noise, we've all seen SE Noise. We've used it dozens and dozens of times, and we'll notice that it's not called a noise node; it's called SE Noise. And there's a reason it's called SE Noise, is because all of this is actually behind the scenes. Is actually done by SeExpr. And we can actually reproduce the vast majority of everything in here. Actually, we can do everything in here inside of it, with the exception, I can't tell you getting the exact pattern match, but we can get a lot of it. So what we're going to do let's start off with the SeExprSimple. I'm going to just close this so we can see this. Here we have SeExprSimple is channel based versus the regular one is works overall. So actually, I'm going to actually go over to the main one for a second. You can see the main one is broken into two things. It has a RGB script and an alpha script. So, for example, in our SE noise, we have a thing called just noise. So if I type in noise, and I were to put in something, if I just put in, if I just put in something like, it works off of both X and Y, or U and V. You can put U, or you can put V, or you can put X, or there's this thing in Natron called CX. We're going to just, for right now, let's just start off with, we'll just use U. All right, we'll just say U, and I'll just type that in, and I'll hit return, or I click out of the script window, and it creates this thing, and we just see this kind of gray thing. It really isn't that impressive, and the reason is because it is taking up too much of the screen. This is called a scaler, okay? And what it means is that it works off of these coordinates of scaling the patterns and the things in it based off of some form of thing. So we have to scale it based off some multiple or divisor. So we're gonna, I think we could just type in, I can't remember if we have to make it bigger or smaller, or off the top of my head, because I usually don't do it this way. I actually think we do with the U, I think we do it by, well, we'll do it times 0.01. If it doesn't work, nope, that's the wrong way. We got to make it bigger with U. So we'll just make it like times 50. All right, and there we go. We can see it's created a whole lot of vertical lines in gray, and that's not overly useful. And the reason is that this is using just this single value, and it really, what it wants is a vector. And we've only given it a single coordinate vector, which is why it's doing these. U is a horizontal vector, and V is a vertical vector. So when we do V, it goes up and down. Now, this can actually be quite useful. I'll give you a prime example. This is where it might actually be useful to do something in SeExprSimple. If we take that same noise that we just used, and we were to paste it into the R channel of the SE noise simple, and then we put it in there and let go, it does this repetitive value going up. And then we can paste the same thing into the green channel, but change it from V to U, and lo and behold, we get these two opposing patterns going across the screen. This is something that we can't do right out of SE noise, but it is an actual noise pattern. It is based off of noise. And why would we want to do something like this, you say? Well, what happens is we've been dealing with doing iDistort. Well, for iDistort, if we wanted to distort something, let's take a look at what we can do here. Let's do a color bars. Let's put color bars in here. And then underneath this, we'll take that and we'll put in an iDistort. And then we'll take the UVs and just plug it into there. And it doesn't seem to be doing anything. Let's see, why are we not doing anything with the iDistort? It's possible. Oh, let me just look at my SE noise. It's possible. Oh, I know. I think we have to also tell it that it has an alpha channel of 1. All right. So the problem right now is we don't see it doing anything. That's because, of course, our SE noise, iDistort, we also have to set the value. We got to give it a distortion level. There we go. And now we can see what I've done is I've created separate distortions for both the vertical and the horizontal. And this is something I was thinking about talking about last week when we was talking about, distorting things. You can see we can control it so we get individual distortion up and down. And I can change this by I can increase the value by, here, let me get rid of this so we can look at the noises. So I can change the frequency of this, so I could set it to like 100 here, and then it makes it more You can see that's increased the frequency there, or I can decrease it, set it down to like, you know, let's make it 10. And so we can change the frequencies. That's one of the advantages to it. We also can change the magnitude by just, you know, if I want to make it bigger, this is currently, all we have to do is multiply the result of our noise by a bigger number. So I just say, instead of that, we'll make it twice the size. All right. And so I make it twice the size, and there we go. It's twice the size. Now, remember, I haven't offset this. So if I have to set it to 0.5 and 0.5 here so that it works off of the, whoops, not 0.5, 0.5 and 0.5. That sets it so that this happens at the midpoint, so that the distortion shouldn't be off by much, but it is. All right, so what we've done is, because we multiplied it by 2, we also have to subtract, I think we also have to subtract 1 from it, so that it offsets it. We've multiplied it by 2, bring it back to 1, and that should recenter it, and now it should look approximately, it's a little off. Maybe I need to take it down by half. Anyway, the whole point is we can control it in that way. I don't want to dwell on that particular thing. So there's very good reasons to use SeExpr for controlling individual color channels. Now, we can also, you'll notice that you're saying to yourself, okay, well, this pattern is neat. What else can we do? We also have this. This is one pattern. And as you can see, what the two did is it made it darker here. You can see it increased the amplification of it. So we get brighter brights, darker darks, because we subtracted 1 from it. Yeah, let's put it like that. And you can see this is what it actually is. And we could have just subtracted like 0.5 instead, and it would have offset it a different amount. That's probably more accurate to what it would have been if we had just eliminated it from the, whoops. Oh, I eliminated too much. There we go. That's it original. Yes. So minus 0.5 would have given us a better result. Anyway, but noise isn't the only pattern. We can also say, I can also do, you know, FBM, you know, for fractal Brownian motion. We know that exists in there. And we do that and we see FBM. But this is just doing horizontal stripes. Let's go back to that noise for a second. All right. So what do we do? How do we get this so that it's not just stripes going across our screen? Well, what we do is we have to enter this thing called a vector. And a vector is a 3-dimensional space. You know how we talk about it. We have the, you scale this up. We usually do this uniformly inside of Natron. And the way you enter vectors into this is you put them inside of brackets. And it's 3 digits separated by commas in brackets, and we have to use an axis that it works off of. So the default thing that you might be thinking is okay, well, we know U, comma V, because that's horizontal and vertical, and then the Z is the depth, and this is the equivalent of sort of Z0. Z0 is the depth, and then you have a time would be the multiplier that it multiplies by. And so anyway, we're going to just put it, for the time being, a 0 in there. And when we click off of that, we get this. And again, it's too small because we don't have it multiplied against anything. So we'll multiply it times 50. And then on the U, and then times 50 on the V. And we can take that and we wind up with this. And the first thing that you're going to notice is that this isn't exactly it doesn't look like the pattern out of Natron. In fact, it looks distorted. Even though these numbers are identical, it looks distorted. And I'm actually at this point going to pull this out of, stop using SeExprSimple and just go to the regular one. Let's close that for a minute. And we're going to go here and we're going to paste this in here so that we're looking at this in black and white. So whoops, or didn't we? And we can see it. So the problem we have here is that let's reduce this so that the pattern is more visible. Let's take it down to 10. And we can see that it doesn't line up. And the reason it doesn't line up is because U and V are coordinates that are based off of the size of the polygon. Well, this polygon is the U is just the width, is a different is different than the height, which is the aspect ratio, and that can change all around the place. And there are other coordinate systems. In fact, I'll give you a quick tip. If you don't want to go anywhere else inside of Natron, on both of the nodes, they have this little help button. And if you click on this help button, it pulls up a lot of stuff. And it's in black and white. So you might want to, if you search this up on the web, you can actually see this color-coded a little bit more. But it tells us a lot about the things and some of the coordinates in here. And you can see that it has an X, it tells us it has U, and then it has this SX, which is a scale X, and then it has CX, and you'll notice that it has this thing called PAR. PAR is the pixel aspect ratio, and the pixel aspect ratio is how the SE noise is distorted. And CX, using CX and CY, we automatically compensate for any view, no matter how we scale things, the pattern will stay uniform. And that's important because the problem we have is if we use U or V or X and Y, if we change the ROD, the pattern will jump up, will either scale with it or will distort, it will look consistent. So whenever we use things, we really don't want to use U, V, or X and Y unless that's an important factor to whatever you're trying to do. You should most of the time stick to using CX and CY, all right? And so let's go over here and we'll change this to CX and change the V to CY and see how that changes things. And suddenly it's gone all to pot. It doesn't look great. Well, the reason is because now that it's working off of a pixel aspect ratio, it actually works off of division as opposed to multiplication. Or if we are going to do it via multiplication, we need to do it in fractions. So instead of being 10, we'd put it at 0.1, and we change it to 0.1 and times 0.1, and we should wind up with something a little bit better, but different. All right, and so there we go. We see something here. But it's not looking quite right. It's not looking like what we expect. Well, I'm going to first tell you about, in our SE noise, if we go back here to SE noise, we have this thing called noise size, and it says 350, all right? One of the things about this is we can create variables inside of this. It's very easy inside of SE expression, or SE. I'm going to call it SE expression. It's because that's what I think of it is, and I think it's actually pronounced as I say SE as in see, as in visually. You see the results of this. I think I might have mentioned that earlier. Anyway, but because there's also a programming language called C, or don't recommend calling it C, because if you say C expression, people will start thinking you're talking about the programming language. So refer to it. It's much easier if you call it SE. Can't tell you when I've had talks with Mr. Morley about it, how it's gotten into clouded our conversations a few times. Because he's referred to it as SE. Anyway, what's that mean as C? And I'm like, what? Anyway, all right. So we can create a thing called size, right? Size equals, just so you know, usually inside of this, inside of the Disney world, when you do this, you usually precede things with $sign. It's optional inside of Natron. You don't have to do this. But as soon as you put in $sign and type in a variable name like col equals, and then if I were to define a color equals and I put 0 in here, all right, and all right, and then I put in this semicolon, you can see in the editor it actually creates this it creates a variable that we can, pull up and scroll up and down, and it changes this automatically. And col equals 0 doesn't actually do anything because it's not actually tied to anything. But over here in ours, we need to sit here. This works off of closer to C programming language or Java or C++. Anybody who's familiar with those, you need to use semicolons when you're doing multiple line expressions in those types of languages. And SeExpr is no exception to that. All right. So if I want to make a noise and I want to say 350, all right, let's say 350, and I hit semicolon here. And instead of multiplying it times 350, or actually, no, I am going to do it, multiply it times 350. What I'm going to do is I'm going to do CX times 1 divided by size, all right? And that is going to give us our actual scale, but as a multiple. And that's very important because we want, you don't want to get divide by zeros errors. I don't think we might still. I don't know. If you do 1 divided by 0, that comes up as 0, right? Oh, I think that is going to give us a divide by 0. Oh, well, we might want to, you might want to avoid doing that. Anyway, whoops, comma 0 there. All right, so there we go. So this is a noise. This is noise. All right, working off of a size. Let's see if that matches. All right, we go over here to our SE noise. We'll switch this to noise. And there we go. We have that. We go here. Look at that. They both match. The patterns don't match, but they pretty much match as far as what they actually look like. So this tells us the fundamental thing that our size inside of our SE noise and SeExpr is just 1 divided by whatever this size number is. All right. So there's another thing inside of, there's something inside of this expression editor here called $P. All right, and it's a tricky little bugger. All right, if we type in $P in here, we get this funky thing. Oops, it's not that. It's capital P. All right, if I hit apply, we get this. All right, and if I type in for example, FBM, which is a different noise pattern, as we know, and you can see, here's our code completion inside of this little Disney editor, we'll call it FBM, all right? And it tells us that we have to do a vector, all right? Our vector, we're going to do $P, all right? And, whoops, capital P, all right? If we type that in and we hit apply, we get this as a pattern, all right? So we've created that. We say, oh, great. We get this lovely FBM pattern and it's there. And it's nice and it's uniform. Everything looks great. And this is, by default, P is sort of this normalized super variable in a lot of expressions. And it's used in a lot of the SE noise expressions inside of here. But we run into this problem that if we try to put it in here, let's just, for example, put in... let's comment these out, by the way, if you put a hashtag here, and I just type in here, $P inside of Natron, we get an error. $P does not exist inside of Natron by default. So the question is, this creates a lot of problems inside of Natron, because it means we can't just take code that's coded, almost every other program out there uses $P. So what we're going to do right now is teach you how to make $P function inside of Natron. All right, and we're going to also talk about some other things about it as well. So we're going to define $P. We're going to actually get rid of the $, first of all, and we're just going to call P equals. All right. So what does P equals? Well, P in Natron, keeping it uniform so it scales, all right? Because that's important. We want to scale it. P is going to be equal to the, it's going to be equal to our C. We're going to say, actually, we're going to take our size here and we're going to change it, put it above here. We're going to rename it, and I'm going to change it from size to V size, for vertical size. And that's going to be important. And for my vertical size, I'm going to actually make it, for right now, I'm going to stick it to keep it to our horizontal resolution. For our vertical resolution, a vertical resolution. Boy, it used V. I don't know why I'm doing that. Anyway, this is a 1080 screen, so I'm going to just say 1080 there for right now, all right? So I'm going to say P equals bracket, all right, CX divided by V size, all right, end bracket, all right. We're going to be taking the result of that. This is going to take the CX and it's going to divide it by our vertical size, which is going to scale our texture to match whatever our resolution is. All right. We could actually take our input resolution. In fact, that might be a better thing if you want to make this more dynamic, but that would mean this will adapt dynamically to whatever size. It's going to scale it up and down whenever you change your resolution, which is what we're trying to avoid. We're trying to create something so that it matches what our current screen is inside that editor. All right. So when we look at a pattern in there, it's going to match in here. All right. So I'm going to do that. I say, all right. So it's SeExpr, and then we're going to from this, we're going to do minus, because we're going to this. We need to offset this minus 0.5. All right. And we don't, which is half a unit. All right. And then we're going to multiply it times 2. All right. So that's our first value. And the reason what we're doing here, let me try to explain this. The V size scales the entire texture or coordinate space up to match the height of our current view, which is 1920 by 1080, 1080 being the shorter of the two heights. And you can set this to whatever size you want. In fact, one of the things I suggest people do is multiply this times a number that you can scale, and we can add in a scalar parameter here. In fact, let's do that right now. These are parameters that you can control through Natron to change something. So here we've added this x1. So if I change x1 to 1, and I'll change this from 1 to x1, now I can drag this up or down to change the scale of my noise. All right, and we can change our size. All right. But what this has done, this is an offset. We're offsetting it by what we set it so that it scales the texture up, but then we need to offset it in space by half of our coordinate system, which is basically over halfway. And then we need to increase it by 2, or double it by 2. And the reason that we're doing it is that will produce this. If we just go back to, we're trying to reproduce this as a physical texture, where this is happening. This transition here is happening approximately halfway across our thing. If we had done this normally, it would start off with the coordinates down here in the bottom left-hand corner, which wouldn't align with these. We want it to be at the halfway point, or that what would in theory be halfway point of our unified units. All right, so I want to move it out so that when this comes up, that this vertical matches, but the horizontal can be wider. All right, and we're going to prove that this is going to work in the future. All right, so the next thing we need to do is we need to take, that is what this does. The doubling makes it so that we scale it so it's darker, so we get that black on the left and the bright colors on the right. That's what this is doing. We're doubling the amplitude, and this is shifting it off to the side. But we don't want to do it just to the X. We also need to do it to the Y. All right, so we're going to select here, back to this. Wait, hold on. I need to just double check to make sure I'm getting this right. Yes. So what we did, this is in a parenthesis to keep this. We want this calculation to happen first, this division. Then we want to subtract the 5 and then take the result of all of that and to multiply it by 2. All right. That's how what it's currently doing. All right. So then we take this. We're going to copy it. We're going to hit comma. We're going to hit paste, then we're going to hit comma, then we're going to paste it down again, all right? And we're going to change it. All we're going to do is change CX to CY, all right? And that is going to give us our uniform space that keep our coordinate space. And then we're going to tell it 0 is our depth, All right, so we've got our X, we've got our Y, and we've got our Z is 0. And if you want to change the depth over time, you would animate that 0. If you want to change your horizontal position over time, you would take and change, you would add something or subtract it relative to X, and then you could do your other things in other points. But here we go. So that's given us, we have our 3 coordinates. We have our X goes up to here to our first comma. We can hit space there. Our Y goes up to our second comma, which is here. And we can put comma space. And then Z is 0. We want to bracket that. We want to hit a semicolon at the end to say that this is the end of it. We've finished defining P. All right. And then we'll go in here and we're going to change our noise from what it was to P. Whoops, to Shift P. Because when we hit return, whoops, we need to uncomment it, and then when we hit return, so there is our P, that's noise P. Let's go over to our original one over here and just type in noise parenthesis P, $P, and verify that that is the same thing. We hit apply. Oh yes, and here's the other thing. The pattern, you can see the pattern matches, but we have to do one other thing to this, which is this suffers from the same problem that the shader toy node suffers from. It doesn't work. Most of the shaders are not designed in they're designed in RGB color space. So we need to put OCIO color space transform here and change it from it being an sRGB or to being an sRGB. And now if we go back and we look at these two, lo and behold, look at that. We have something that looks pretty much the same, does it not? What do you think, Mr. Morley?
Looks the same to me.
All right, we have a pattern match. If anybody doesn't think this matches, tell in the thing. And well, in fact, let's prove this. Let's actually copy some things. Let's just copy something from in here.
There's a bunch of them in the warp section.
Warp. Where down? Where's the warp? How far down is warp? Cloth flat, green.
Quite a ways.
Warp. Here's some procedural. Oh, I like the procedurals. There was a grunge. Oh, there's a grunge one.
Yeah. The
directional streaks. All right, so here's directional streaks. I love this one. Look at this thing. That's crazy. You say to yourself, oh, that looks crazy. We copy this, all right? So we copy this. We go back into here. Let's just prove. First of all, we need to isolate this because we don't want to. I'm going to put a hashtag and a bunch of lines across here to isolate our P. We don't want to do anything to anything above there. And we're going to just go paste all that below that so that we have our P defined up there. And then we got that. And we hit click out here. And lo and behold, look at that. There we go. We have the same thing. All right. So you say to yourself, all right, well, that's, first of all, cool. Because we don't have this pattern inside of Natron by default. That's the cool part about it. And there's tons and tons and tons of noises in this program that you can look through and stuff. In fact, Mr. Morley, do you have any examples that you would like to show us?
Now, this pattern is awesome, but do I have to go in there and hard code it every time I want to change the size of the pattern or the look of this pattern? Is there any way? Is there any way that I don't have to hard code it, but I could use sliders?
Oh yeah, well, all right. We already see up here. We put in this V size equals 1080 times x1, and in our scalar parameter, we added this scalar parameter of 1. So this x1, there are 3 types of parameters in here. It's really arbitrary. First of all, these parameters really, they're designed so that we have one-dimensional scalar parameters, which are referred to by the name x and a number. So if I change this up to, I can increase this, and you can see I have x1 through 6. And over here, if I change this, watch what happens to our pattern, because we already have x1 in here. If I change this parameter, if I change it down, it's going to take it a second. See how our pattern is shrinking because I'm shrinking the pattern value. Or if I increase it, I can make it bigger. I can take it above 1. And it takes it a little while because it has to calculate out the numbers. So yes, you can manipulate it. And that's the whole point. You can put in these variables. So, but what are these?
So I could change, for instance, like the streakiness that's set to, I don't know what, .5 or whatever. I could change those variables to the X2 or X3.
Correct. Let's okay. Actually take, let's take this streakiness, which is 5.662. Let's give ourselves a new variable in here. Now, the one unfortunate thing is by default, when you're using these, if you don't want to create custom node or custom sliders, user controls, you have to deal with them by arbitrary names of X1, X2, etc. That's the unfortunate thing. But let's put, whoops, oh, didn't copy that. Let's copy that and put that in here. Paste that in there. Why is that? All right, let's just, I don't know why that didn't do it, but whatever. We'll put in 5.662. All right, we put 5.662 there into X. Oops, that I did it to the wrong one. Let's put that back to 1 and put this to 5.662 to 2. And then we're going to go over here and we'll change this to, instead of 5.662 here, we can put in X2. All right. And then now you say, okay, well, it didn't change. That's because we have it the same. Well, let's see. We'll change it to 4. I don't know what it's going to do. Aha! Did you see it shrunk down in the vertical direction? We'll shrink it down to 1. And there's what it looks like when it's unstretched. Awesome. And if we set it to like 9, we should get really stretchiness. And there it's stretched out a lot. So we can see that adds, we can stretch it that way. And obviously that's just a vertical stretching of the texture. So we can do that. So we should point out at this point, there are these other two things, and I'm just going to create one. So we have, they're called scalar parameters. It's like scale, but with an I. Instead of scalar, it's scalar.
Arr.
Because they're obviously whoever created this was a pirate. They're okay, which means they're okay in my book. All right. Anyway, so they're called scalar parameters, and we're going to be, so that's what the one-dimensional, they're all called scalar parameters, but the 2D parameters are called, or 2D vectors are called positional, and they give you an X and a Y. And then the 3D ones are X, Y, or are called color, because you can actually enter colors in here. And you can do it, you can actually enter colors, but you don't actually have to use them as color parameters. You could do this, you could actually set up your parameters so that you're controlling your size, your vectors, from inside here, or your multiplier by the CX and the CY inside of here as part of a 3D, vector or whatever. But honestly, it's really useful for color because, you want to do like blue. There's our blue, and then we could, do whatever and increase it and whatnot. And the cool part of this is that SE noise, or I should, excuse me, SeExpr is really, really, really powerful. It does far more than this. We're only looking currently at, just doing noises. And we've done a noise. As you can see, we've merged a whole bunch of noises. This isn't our default noise inside of it. It's a combination of funkiness mixed with noises, a mixture of noises to get this really cool pattern.
So it almost seems like you could use this for maybe even just merging.
Oh, you can do it for merging a whole lot of things. That's a really good point, Mister. In fact, you'll notice that it was it's listed as a merge node. You can do a lot of things inside of this. You can merge nodes. All right. So how would we merge something? Let's look at this. You'll notice that inside of here we have. Let's take. In fact, let's just take the two things we have here. We have an SE noise. We have a color bars. All right. So how do I access this? Well, this has inputs in it. In fact, you can do up to 10 inputs on this SeExpr. And the way we access them is through this thing called SeExpr capital CS, all right? CS is stands for color source, all right? And when I type in CS1, that tells it it's going to use color source 1, which should be, it will return our SE noise. So I do that, and there's our SE noise, all right? If I change that from CS1 to CS2, I get my color bars. So no matter, I can do it from 0 to 10. Or excuse me, it's not 0, 1 to 10, all right? And the cool part about it is that what happens if I want to mix these nodes? Well, there's a wonderful command in here called mix. If I type in mix inside of SE here, and just to show you, just so you guys understand why this is really useful, let's go back over here to this and just delete this. If I type in MI, you'll notice here that underneath this, there's this node called mix, this thing here called mix. All right, and so this is why I recommend downloading this editor, is because a lot of this stuff, by the way, the editor does not support CX. CX does not exist inside of this. It is a Natron specific thing. A lot of the different programs have their own coordinate systems. CX is Natron specific, but $P is not, which is why I showed you how to make $P inside of Natron, and we can make it so it scales so that the texture you see matches whatever your output resolution is by default. Anyway, so there's this thing called mix. If we go here and look at mix, it tells us that it's float A, float B, float alpha. Well, what does that mean? Well, we got mix, and we can say, well, we know that we're feeding it things. If we say CS1, comma, CS2, comma, we'll keep it for right now 0, all right? And then I hit, and I just click off of this. I've just mixed it. I've mixed these two, and it doesn't look like I've done anything here. But what I've done in actuality is I've mixed it so that my mix is at 0. So it's showing the SE noise. And if I change my mix to 1, it's going to show my color bars. Well, what does this mean? Why is that useful? Well, I can also put in FBM for fractal Brownian motion. And I can put in here, P for my combiner, which up here, we're going to use, which is telling it that we want to use our P as our vector for our FBM. So when we click off of it, we wind up combining the two via an FBM. Now, it doesn't look overly exciting because an SE noise is a grayscale image. But actually, this raises a good point. All right, SE noise is gray. It's gray, but here's something cool about, let's, for the moment, just comment this out. I'm going to comment out this, and above this, by the way, if you don't, just so you understand, your last command that you type into SE noise, or I mean to SeExpr, your last command, whatever the last command, don't put a semicolon at the end, and it will consider that the output. That's how it deals with the output. So the reason I'm commenting this out is because I don't want this to be the output. What I'm going to do here is I'm going to put in a different thing, something we've never seen before. I'm going to put in a thing instead of noise. I'm going to put in C noise. Okay, and you say, well, C noise. What's a C noise? Parenthesis P and parenthesis, and we're going to just hit C noise. What does that do? Why didn't that work? Oh, because we're not looking at the SeExpr. There we go. Look at that. C noise. So if I take my noise and I put C in front of it, it creates random colors. Well, that's pretty cool. Right? If we say C noise, or if we go, yeah, but right, we put C in front of it. What happens if we put CFBM? Oh, well, we get color FBM. Hey, that's pretty cool. Here's something else we can do. Watch this. If we multiply this, we've been doing all this multiplication up here. What happens if we hit times 50? Well, I don't know. I don't know if this is going to work. Whoa! we can actually change the scale of things relative to the whole what we see. We can change all the vectors at once. So we can say, you know, if I can scale it here if I wanted to, as opposed to up here. But remember, this is also scaling the Z as well. So we can change the pattern. So I can change all my patterns. I can do all this interesting noisy stuff, and we've gone a long time. So why is this useful? Well, let's say that instead of this being, I'm going to use this. I'm going to say I want this to be my source. So I'm going to just put this into, I'm going to call this cull. I'm not going to call it color, because color, if I use color, you can see up here, our internal parameters are X, pause 1, color 1. So you don't ever want to use color 1, you know, because otherwise you're overriding the internal parameters. Although I could use the color 1 if I wanted to, but I'm going to say col1, col1 equals CFBM, and then I'm going to say instead of this down here, and we're going to put a semicolon after that, so it's assigning it, and then I'm going to say col1 here. FBM, and then we're going to uncomment this, and then we're going to click out of here, and it's going to merge the two. So now you can see a much more interesting thing. Now we get to see this, and we get to see how it's using that as our mix for it. And what's really interesting is we can actually mix onto the mix, because we can actually take a mix node. Watch this. Let's take our mix node, the result of this, semicolon, and we're going to assign it to col2 equals that. And then down here, you're so, oops, it's trying to use that. It's saying, wait a minute, you don't have an output. We're going to say mix, parenthesis, col2, comma, col1. Do we have a col? Yeah, col2, color 1. Let me just think about this. It's going to be, this ought to create something that's not going to really be that interesting. Let's see. I don't know. Yeah, we're just going to do C. I'm trying to think of a noise pattern that's really interesting. You know what? CFBM. Whoops. FBM. Parenthesis P times, let's make it just a noise, 100 in parenthesis. All right, so, oh no, yes, comma, and then we're gonna, let's instead of mixing it with an FBM, we're gonna mix this one with a noise, just noise, whoops, N-O-R-S-E. Parenthesis P, parenthesis. I'm just using P because it saves me from having to calculate out my own vector here. And then we got to put another parenthesis there. And lo and behold, we should wind up with, let me make sure I've done this. It says I've made no name dollar sign. Oh, aha. I used a lowercase p there. That's why it made a mistake. There we go. So it looks weird, but you can see we've created this really funky, dunky little thing. So you can literally layer these things together and make them anything you want. In fact, I've got an idea. I've got a really good idea. Quickly, let's do something here. I'm going to make this just for the sake of argument. A few weeks back, we did the fire. We're going to do this as, I know we're running long. We're going to make this is a complex thing. We're going to do something here. We're going to change our color parameters up to 3.
Bonus round.
Bonus round, that's right. The other day, we said we did 1, comma 1. Whoops, let's delete this. 1, comma 0.007. Right, and then here we did 1 tab 0.07 tab 0.07. And then on the last one, we kept it black. That look familiar? What does that remind you of? Oh, come on, Mr. Morley, anything?
It looks like a fire.
Oh, it looks kind of like the fire. Let's do mix parenthesis. We're going to do color 1, comma, color 2, comma, FBM, parenthesis. We're going to do P, comma, oops, we're going to do capital P, comma. Now, this is not going to be an animated one at this point. We're going to just use P for getting our fire. P, comma. Now, FBM has other things other than its position. It also has a thing called, by the way, Mr. Morley, I'm hearing something coming from yours, a voice or something in the background. Anyway, just letting you know. It has, you notice that it had, we had octaves, and we also had the what is it called, the Lucrancy, where is it called? We've got this up here. We have, let's go back to our FBM here. We have octaves and the lucranularity, all right? Well, those also exist in here, and they default to 6 and 2. So down here under, whoops, let's close this so we can get back to this. All right, so down here, and so we're going to put in 6, 2 to keep the defaults. And then we have our gamma, or our contrast, which defaults to 0.5. And as we remember, we upped it in our fire. So if I put 0.7 there, let's see what that first does. That should give us something. Oh, I didn't hit parenthesis at the end. I hit 0. There we go. We hit parenthesis. I think this is, why is it saying? Oh, because we don't have a double parenthesis. That's the end of the FBM, not the end of the mix. There we go. End of the mix. There we go. So we have something that looks a little bit like our fire. Let me pop up to our SE. All right, that looks a little more like our fire. It's not perfect, but it's close enough. All right. So we take that. We're going to take that and we're going to say col1 equals that. All right. Col2, we're going to make col2 equals, we're going to take our mix, we're going to copy it, we're going to, oops, not colo, we want col2 equals mix. We're going to use this exact same thing because we're using the same FBM pattern, but this time we're going to be, let's see, we're going to be taking we're going to take the result of that, I think. Yes, we're going to do col1, and we're going to remember we double mix color 2, so we want to multiply it twice. So we're going to use it twice here. Oh yes, and we need to put a semicolon there and a semicolon here, which gets us this. All right, and so there's our second thing. And then what we're going to do is we're going to make this last one. The last one was going to be our out. So we could either assign it to a thing called out, which we could move down, or just put in the mix directly. So we'll paste in our mix again, which is going to use the exact same thing, except for this time it's going to be col2, and then 0 because, or actually it should be, we'll use color so we can change it, color 3 in our pattern. And this should result in, all right, so what have we done? We took our color 1, let's talk about this so we see what happens. We're making a variable called col1, which is a mixture of color 1, which is our yellow, color 2, which is our red, and we're using an FBM with, all we're doing is increasing its how much it's its contrast, so you see more of those bits and pieces, nuggets. Then we take the result of this and we're making a second variable called color 2, which is a mixture of color 1, which is this line up here, and then mixing that with color 2, which is our red here. Okay, so this, which is the ultimate resulting pattern of those two mixed by the FBM, and mixing it with the color 2 again. So we mix red and red twice. This gets us that haloing, aka using the pre-multiply, or applying the pre-multiply with the FBM. That gets us the double red to make it the red stand out more. Then we're taking the result, and we're assigning that to color 2. Then we're taking the result of that, and we're mixing the result of that as our top. I believe this is A over B. We're mixing this over this via FBM. That's the way I have it. And the color 3 is our black. Color 2 is our result of these two merged together, and we're doing it by the same FBM pattern. All right, let's see if that works. Lo and behold, we have something that looks a heck of a lot. It's not perfect. I think we may need to adjust this a little bit. That's very weird that it's not giving us exactly right. I have a feeling it has to do with the P or something. This should be giving us a better result than we're getting, and I'm not sure why. Let's try doing something. We might have to just... I don't want to keep this going any longer than we already have. Anyway, this is giving us... I'll try and figure out why this is. But there's, if you play with this, there's another thing. I'll tell you right now. The result of this is sort of good. This is giving us sort of what we had before. I'm really puzzled by this. This should be giving us... Huh. I really don't know, but I want to troubleshoot this to give you an answer, but I can't do that right now because we're running long. Anyway, Mr. Morley, do you have anything you want to add? I'm sorry I didn't come back to you as much as I wanted to.
No,
Mr. Morley, I'm gonna...
I put a lot of the stuff in the streams for where they can find the stuff on the websites. Download the editor and the quick reference and some other things there. So it's good stuff.
All right. Well, this is just our first exploration into this. Trust me, we're going to be doing more with this because while this is one way of making the fiery thing, and I haven't gone into how to animate it, there's actually a better way that works actually faster for things that use repeating patterns like this, and we can do some really exciting, cool things that most people actually can't do. But we're going to do that in a future episode, not this one. So thanks for tuning in. You've been watching again VFX with Natron with Mr. Tom Morley,
And
Esquire, and Pirate Bill. That's right. So. Thanks for watching. Keep on Natronian.